Okay guys, today I'm going to walk you through what an ideal senior level answers look like for the Kubernetes Private Registry question. The question was, how do you configure Kubernetes to pull private images from multiple container registries following security best practice? The candidate answer was,
This is regarding the configuration and the best practices that I would follow while configuring it, right? Okay, so in order to configure the components, pull your private images from multiple registers. So first, you can create a separate image, like image pull secrets for each private registry. So I can tell you with an example, like let's say you have one secret for GCR and one for the Portman Private Registry. So what you will do that in case while we are registering, initially we need to take the secrets, and later on that I will use the kubectl and I will create the secret Docker registry for that. For GCR, I'll use the service account, and we have the JSON key, and for Portman registry, I'll use the I'll configure the images that pull secrets, and I will make sure that I have configured it correctly. And for the deployment, I like deployment YAML, and I'll configure the images and pull the secrets. And this is what I do.
okay, sure. Now, instead of just walking about kubectl commands, I want to explain the architecture visually, because senior level think is architectural, not operational. Okay, the candidate showed solid operational knowledge. She correctly identified the need for image pull secrets and knew how to use kubectl to create them. She has hands-on experience and understands the basic flow. However, the answer was architecturally shallow. She focused on static credential and JSON keys. In a senior development environment, we avoid this. She missed the critical best practice like workloads identify the eliminate static keys, IAM roles for least privilege, and associate secrets with services account for better governance. Let's break down the diagram step by step. Okay, at the top of the diagram we have two external registries, GCR, which represent Google Artifact Registry, and Podman Registry, representing a private container registry. These are outside the cluster. This immediately tells us something important. The cluster must authenticate externally and securely. A junior level answer usually stop at create a secret. A senior level answer asks, how do you authenticate securely? How do we avoid static credential? And how do we scale this for multiple registries? Okay, now let's move into the Kubernetes cluster. Notice the large boundary box. This clearly separates external systems from internal clusters components. Okay, securely architecture always starts with boundaries. Inside the cluster, we first define a namespace production. This matters. Why? Because secret, service account, and RBAC are namespace scoped. Good engineer isolates environments properly. Now we reach the most important component in this diagram, the service account app/SA. This is the key architecture decision. Instead of attaching image pull secrets directly to the deployment, we attach them to the service account. Inside the service account, we define GCR/secret and Podman/secret. This means any workload using the service account automatically inherits those pull permissions. Why is this better? Because it centralizes credential management, reduces duplication, and improves governance. Okay, now let's move to the deployment. The backend deployment reference the service account name app/SA. Notice what we're not doing. We are not defining image pull secrets inside deployment YAML. That is deliberate. We separate identity from workload definition. This improves maintainability and aligns with least privilege principles. Okay, now let's look what happens during the pod creation. When the pod starts, it needs to pull an image. Kubernetes checks the service account. The service account provides access to appropriate registry secrets. The cluster authenticates against GCR or Podman, and the image is pulled securely. Okay, now let's talk about the security layer on the right. This is where the difference between mid-level and senior engineers become clear. A mid-level answer stop at secrets. A senior level answer includes workload, identity, IAM roles, RBAC, security rotation, image scanning, and OPA policies. Workload identity eliminates static JSON credentials. IAM roles ensure least privileged access. RBAC controls which workloads can use its service accounts. And OPA policy enforces cluster-wide compliance. This layer ensures that even if the registry works, it works securely. So that's all you needed to know to answer this question accurately in order to show that you are a senior level developer. Okay? Thank you for your time.